Welcome everyone to the webinar Enforcing Application Security at Time of Deployment. My name is Mark Levy, and I'll be hosting today's webinar. I focus on product marketing here at OpsMX. Before we begin, a few housekeeping items. The session today is it's about 45 minutes long. We're recording the session. We'll send the recording the slides to everybody. And if you got any questions during the presentation, please put them in the chat and we'll answer all the questions we have at the end of the presentation. So just a quick overview for those of you who are not really yet familiar with OpsMX. If you could go to the next slide, Bob. OpsMX delivers software and services to intelligently secure and automate software delivery, leveraging an open DevOps architecture and deep CI/CD expertise to empower enterprises to ship better software faster. Check us out at OpsMX. So I'd like to introduce our presenters today. Bob Boulay is the first one. He's VP of Product here at OpsMX. Bob has spent the last 20 years or so in both software engineering and product management, focusing on software delivery and security, which makes Bob uniquely qualified for today's presentation and discussion. Gopi Ribala is our CTO here at OpsMX, where he has overall responsibility for the machine learning implementation and architecture of OpsMX solutions. Gopi has a strong connection with our customers as well, leading design and architecture for strategic implementation. And he's a frequent speaker and well-known leader in the continuous delivery and Spinnaker community. Welcome, both Bob and Gopi. How are you guys doing today?
Very well. Thank you, Mark.
Great, Mark.
Welcome, everyone.
All right, let's move on. I'm anxious to hear.
All right, guys. So just a quick overview, guys. The way we're going to structure today is Gopi's going to help us out with sort of understanding from a thought leadership perspective and some of the things that are happening in the market that led to us, really sort of coming up with this concept of a deployment firewall. He's going to walk us through the whys and some of the attacks that are out there in terms of the ecosystem for deploying software, and talk to us a little bit about sort of the thought that went into sort of development around secure software delivery. And then from there, I'll take over and sort of from the product side and walk us through sort of what is the deployment firewall, how does it work, and how do we operate it? What role do the SBOM of the software bill of materials in the delivery BOM play? And then ultimately, as we move down the list, looking at how we leverage the data in the CI/CD ecosystem, and sort of how the data is evaluated as part of this process. And then we'll wrap up with sort of a tour of what the deployment firewall looks like in a real world scenario. So hopefully, that it's an interesting way for us to spend the next 45 minutes or so. And as I said, I appreciate everybody's attendance and looking forward to a great session. If you do have questions, please let us know. And if we don't have the answers for you now, we'll certainly follow up with you straight away right after the session. So with that said, I want to turn it over to Gopi and let him talk a little bit about application security and the supply chain.
Thank you, Bob. So this talk is about the deployment firewall, but we wanted to give some motivation why we came up with the solution for deployment firewall. And Bob will obviously walk you through what it does and how you can solve some of the problems that we see today. So mainly the things that changed in the last couple of years, maybe a year and a half, are the increased surface area of the attacks for the supply chain. We'll go through a few of the examples and see what that means. So here, the supply chain generally is defined as all the way from code, your source control management, to the deployment where you're running your application on the other end. And so with that, the surface area now exposed has been the attacks on your build systems, source control systems, third-party libraries that are included with the open source software, and repository systems, and at the time of the deployment, not necessarily malicious, but the non-compliant systems being deployed. There are many places where the security issues can creep in. And so with that, there are increased compliance violations that we are seeing in the production environments. We are also seeing some of the systems that are running software with vulnerabilities that haven't explicitly been taken exceptions to. So the increased application complexity also contributes to multiple microservices, dependencies, multiple teams, and making it much more expensive for the audit and responding to incidents. Once you find an incident, how do you trace it? How do you find the root cause of the problem that's introduced? Is it due to a malicious attack, or is it the third-party software that's included by mistake, or things like that? So clearly it needs a new way of thinking and identifying how to solve these problems in your delivery of software, so that you can secure your supply chain. So if you go through some of these attacks, when we talk about supply chain, the most common one that we hear is the SolarWinds attack. It took more than a year to identify that there was an attack, and that had a wide range of fallout, with large number of companies affected by it. If you look at the recent attacks, even the Circle CI attack, where the Circle CI is one of the companies that provide continuous integration SaaS services to their customers, has some of the continuous delivery as well. And the credentials for one of the admins got compromised, and it wasn't immediately identified that there was a compromise. So that affected the security of customer systems. And a homebrew cask attack, it's just a couple of years ago, where the central repository that's holding the libraries, which the dev tooling libraries, were compromised, and the developers who are installing the software, all of them got affected by it. It was looking for some secret keys that for exfiltration, identifying the composition of the software on the systems to find additional attack vectors on it. So NPM.js is also very interesting one. Recently, someone created Math.js min component that looks very similar to Math.js. It basically does exactly what Math.js does, except it has one of the functions that has malicious code in it that would identify the tokens and exfiltrate those tokens. And so it's very difficult to identify these changes. So we need a new way of looking at the supply chain and securing your supply chain. So that's the primary motivation. But what are the challenges in trying to stop these kind of attacks? So if you look at the next slide, we would see that there are security point tools that are currently in place, and we have the SAST tools, we have pen testing tools, DAST tools, vulnerability checkers for the binaries. But those are not sufficient, because the attack surface is increasing, as we saw in the introduction as well. The supply chain, it's the delivery process itself can be compromised, and there are different systems and policies that can be compromised. And if you want to look at the data as a whole, typically in organizations, larger ones particularly, there are multiple groups that are using the tools that each of these groups have their own certain changes that they make to those tools, or identify some tools that are best suited for them. So in those cases, enforcing security centrally or providing guidance on these rules and verifying those rules are being followed becomes very difficult. And also in some of these cases, like Sarbanes-Oxley process requirements, there are approvals that may be required by more than one person. Now, sometimes these are not automated, and then the manual steps slow the process. And because of the slowness, sometimes these exceptions are taken and those are not tracked. So that becomes a compliance issue in the security hole in your system of the delivery. The vulnerability tracking itself, because there's so many vulnerabilities in the open source, when you include them, you take exceptions for some of these because they don't really affect your software, but some of them you do because of expediency, but there is no clear tracking mechanism. So if you want to go look for the compliance at a later time, you will find the software that you are running is non-compliant. Now that becomes a security issue. At this point, the audits also becomes very expensive. So if you want to prove that your system is secure or prove that you're compliant with SOC 2 or PCI DSS, you'd be looking at n number of these systems, and that takes a very long time, and it becomes an expensive process. In the changing regulatory environment, the SecOps groups providing guidelines on what rules that you want to follow, having those rules specified to the developers and having them follow becomes a fairly large training process, and it makes it very difficult to make any changes to the security process in the regulatory environment. So these are all the problems that we see can have with proper solutions that solve these problems. So this is when we realized with our delivery expertise, with all the tools that we already have, the integrations, there is a better way for doing these. So now I'll hand over to Bob to walk you through how to solve these problems and what we are doing to address these challenges. Bob, to you.
Great, thanks, Gopi, and thanks for some great information here. I think it's just critically important when we sort of set the stage for these types of solutions that people understand sort of the real world implications, right, and the real world problems that we're solving. So that was great, and I think people now have a better sense for the why around considering something like this. So let's talk a little bit about what the deployment firewall is and how does it operate. So essentially, what deployment firewall is a rules-based enforcement engine that evaluates a set of rules that are typically implemented by our customers, and ultimately those rules can be data-driven, right? So as we're collecting data from your CI/CD tooling, in terms of vulnerability counts or code quality items, or they could be things like, whether or not the efficacy of the images that are to be deployed, or that it can be proven out. So any of these rules, as it relates to those things, binary security, approval and compliance, infrastructure security, deployment verification, these are all things that play into the checks that the deployment firewall would do. And typically, there's, the software is doing the data delivery or the data collection from your CI/CD system. So you don't need to make a bunch of changes to the tooling that you're using. We just plug us into the middle of that and we start collecting that information. Obviously, there's the definition of those deployment firewall checks that will be done based on your particular environment, based on your specific rules. It could be, again, you could be looking to minimize CVEs. You could be looking to make sure that code quality checks are at a certain threshold. You may have, some SOC 2 Type 2 requirements. You may have some ISO 27001 requirements or FedRAMP requirements. And you may be deploying onto your platform in a managed rollout where you want to do things like deployment verification. And at each step along the way, as you fan that deployment out, you want to make sure certain checks are passed. So the deployment firewall will ultimately do those checks for you, and then ultimately will go ahead and actually make sure that either those things all pass or alerts are created and generated and then sent out to stakeholders to ultimately go ahead and say, hey, this deployment has been blocked. Here are the reasons why. And then at that point, you can close the loop by coming back as an application owner and saying, hey, we need to remediate this process, or remediate this problem, which case you might open a Jira ticket or a change ticket through ServiceNow or something like that. Or you might say, hey, I'm going to provide an exception here. We can deploy what triggered this deployment firewall rule violation is not exploitable or something that we can live with for the next 30 days. And then once that alert is cleared, I can then go ahead and actually re-trigger the deployment process or resynthesize the deployment process to make sure that there are no other issues and that the deployment would be clear to go. So that's the basics in terms of the mechanics of what deployment firewall does, and sort of an abstract method there. And as you can see, the data is flowing, from left to right here, all the way through to a deployment. Now, essentially what deployment firewall is doing is checking rules, right? It's essentially that engine deployment's going to go out, is it complying with all the rules that I've laid out? Those rules may be coming from sort of the ones that we ship out of the box, or you may be importing those rules from your SDLC, or you may be looking to enforce controls that are associated with things like FedRAMP. And again, I think we're doing a combination of things. We're giving you the ability to sort of generate those rules or have us help you generate them, depending on sort of what type of rule it is. And then we're taking the data that we're collecting throughout your CI/CD ecosystem and ultimately validating that data against this rule set. Rules violations, as we talked about, would result in alerts. So that alert would go out to either a group of stakeholders or a single stakeholder, who then would be presented with the problem, right, and being able to take action on that problem. So, but the idea behind this is that all alerts would need to be resolved before that deployment could go out. Now, resolving it might mean, hey, I'm going to provide an exception for this based on these 3 elements for the next 30 days. It might mean that I need to go and create a Jira ticket to have engineering take these 3 actions before we try again. And so these are all things that we're going to go ahead and allow you to do, and we're going to document them as part of that deployment firewall deployment. So you'll have documentation around not only the status of all these things as that deployment has happened, but also any exceptions that get taken or any actions that get taken in furtherance of remediation will also be documented through the deployment firewall. Now, I think that people often ask, well, what role does my software bill of materials play? Or what, for those of you that may have seen a webinar last month around our deployment bill of materials, what roles do these things play? So it's a great question. I think your software bill of materials is a direct input into the deployment firewall. So that data that we're collecting, whether you're generating that as a third-party tool or you're asking us to generate it for you, we're taking that information as it relates to things like the publisher of a package, the license of a package, the vulnerabilities associated with a package, type and version. These are all things that the deployment firewall can evaluate, and you can go ahead and ultimately set up rules that say these things are okay, these things are not okay. So I might say if my open source posture is I'm fine with MIT licenses, I'm not fine with anything that requires me to give back or shift or sort of move left type of licenses. So again, I think and then looking at things like the verification or lack thereof of any of the dependencies that you're bringing in. So these are all inputs to the deployment firewall, and it can be set up to monitor for these things. Again, when we look at our delivery bill of materials, this is another accumulation of data that acts as an input to the deployment firewall. So your source code analysis checking, your branch protection, if you're turning on any of the gas features in GitHub, if you're looking at unit test coverage, you're looking at validation from your build system. If you're using things like Artifactory or you're using Harbor or some of the other sort of image repos, what do the checksums check out in terms of validation of those artifacts? So all these things are inputs into the deployment firewall. But on top of all that, we're documenting all these values as well for you. So that again, as Gopi had mentioned, it makes audit that much easier. But I think first and foremost, with the deployment firewall, we're saying, are these things in compliance? And if they're not, we need to stop the process. We need to alert someone to that fact. And then we need to be able to go ahead and wait for whether it be remediation or exception. But these two things here are direct inputs into that deployment firewall. Now, in terms of enforcement, there's a handful of different ways we can go about doing this. I think that rules violations can be set to do the following. We're going to generate alerts regardless, right? So those alerts are going to go out back to the application owner and bring that application owner back to secure software delivery to ultimately make a decision in terms of what they want to do about that violation. We can do enforcement through leveraging Kubernetes and mission control, or for some of the CD tools that we are deeply integrated with, like Spinnaker or Argo. And by the way, I want to mention, we're not limited to those things. Secure software delivery is really, sort of pipeline agnostic and delivery methodology agnostic. But some of them we do have deep integrations with. And for there, if you don't want to use Kubernetes mission control, you can ultimately go ahead and actually stop the build at the pipeline level and prevent it from moving forward, depending on the violations that have been sensed through that deployment firewall. Again, I think at the end of the day, some users look to leverage soft enforcement, where there's manual overrides based on documented exceptions. But really that's up to you in terms of how you want to enforce these things. For some folks, it's okay to move forward depending on the severity of the violation. Others, they want to stop the presses because they want that remediated straight away. And it really depends on your regulatory environment and the severity of any of the security issues that you bump into. One of the things that we've noticed, throughout our experience here as we sort of start to bring this concept to market is security is always sort of uncompromising, as it should be. Whereas policy and some of these other things, there can be exceptions that are granted, right? Because there's that sort of risk-reward trade-off in terms of moving forward at scale. And I think one of the important things here, guys, is that we are really attempting to replace a process that has the tendency to be very manual. And by the way, we also are able to act or inject as a last line of defense, giving you enhanced response capabilities. So if for some reason a 0-day vulnerability is found in a certain library, of course, you're going to want to go back and work with all of your engineering teams and make sure that we're looking for, sort of all of where those things are deployed. However, with the deployment firewall, you can turn the spigot off and make sure that no additional software that has those libraries gets deployed because of where in the process we're doing this check. And, as part of that CD process, it's very easy to go ahead and create that rule and then ultimately push that out to that particular deployment firewall and cut off any net new deployments that may be in flight and ultimately have that effective library. So we're able to allow you to react very quickly. And because we know where everything has been deployed, because of where we are in the deployment process, we can also help you track down anywhere else within your ecosystem that library sits, and ultimately start to make plans to sort of move that out. I think, when we act as sort of a delivery data warehouse, if you think about all the tools that we're integrating with and sort of the way we're doing our job, it's really about collecting data, right? And being able to allow you to build rules against that data to make sure that things are in compliance, but also go down the path of creating rules that maybe are not associated with these things, that are more, sort of part of your SDLC, again, or part of your compliance and audit package you need to make sure that you're adhering to. So again, I think one of the pieces here, though, is, being able to tap into the entire ecosystem to make sure that we're collecting data from all those tools and creating an actionable and in-context data warehouse for you behind the scenes that allows you to view all these things, as we're going to see as part of the rollout and as part of the demo. So let me go ahead forward here. So, and again, I put this slide together. It's very basic on purpose, right? Because I just wanted to help you sort of visualize how data flows. So if you think about it, data is going to flow from the tools in your CI/CD ecosystem into the deployment firewall logical rules evaluation layer, right? So those logical rules and things that you've set up, and we're going to, in the context of a specific deployment, that deployment might be from QA to staging, or from dev to staging, and then from staging to production. And for us, it really doesn't matter. You can ultimately go ahead and adjust those rules based on the type of promotion that's going to happen. And again, we're going to collect the information over the left from your CI/CD system. It's going to be applied to the logic that's in those rules, and ultimately to our enforcement point, right? So we're going to evaluate those things, and ultimately the enforcement point becomes where the deployment firewall actually takes action, whether or not it allows that promotion of that to happen or not. And the whole time we do this, we're collecting that information and helping you with audit and compliance as well, because we have all this data and we can put all that data in context for you as you look to generate the proof that you've been following these rules. the evidence that you've been following these rules, and you can attest to the fact that the deployment was actually safe. Now, the rules engine itself is really something that we are really working through to make sure that it's simple and easy, right? And you can actually tag these rules based on the part of the process that you want to evaluate. So if it's source code evaluation and you're bringing in data from, say, SonarQube or Aquasec or some other, or Proverity or some other source code type of tool on GitHub, we can go ahead and actually have a set of rules that are just focused on that. The same thing with build, the same thing with artifact validation. So we can bring in rules that are specific to artifact validation, and ultimately you can go ahead and generate those rules. We also have a neat little feature we call the rules genie. So if you've got a rule that you're not sure how to affect in our system, you can invoke or use the rules genie to sort of tell us what it is that you want to do, help us understand what it is you're trying to do, and then one of our CI/CD experts will go off and ultimately help you craft that rule, so you can go ahead and actually bring it to bear as part of the deployment firewall. Again, we want to make sure that the tool is flexible, that there's nothing static about it, that it's able to evolve, because let's face it, the landscape that we're working within here is ever-changing. Vulnerabilities change, the things you have to look for change, regulations change, again, all those things that Gopi mentioned at the outset. So let's take a quick tour of the deployment firewall. I wanted to bring you through this real quick. Want to get to, there we go. So this is ultimately what this looks like, right? So if you think about the deployment firewall, we'll talk about the rules in just a moment, but here you can see the things that are pending approval. So if there's a manual approval step here, that's a part of the pipeline, it will stop and wait for that manual approval step. The ones that are allowed, so these are the deployments that actually made it through the deployment firewall and are actually deployed. And for any one of these, if you want to see the delivery bill of materials here in terms of a snapshot of what was the state of that software delivery when it actually was approved and was deployed. So you see here, we've got passing tests for SonarQube, we've got passing tests for branch protection in GitHub. We know, sort of what the unit test coverage looked like. We know what the artifact scans look like. And so, all these things add up to reasons why this was approved, right? And then ultimately, if you need to extract an audit report, we can ultimately get on the path of an attestation report where you could pull this data out and provide this to an auditor and say, here was the state of this, and here are all the things that happened to that deployment as we went through this process. So again, I think, this is also very, very powerful. Now, for any of these blocked situations, right, I can come in here and say, oh, this deployment looks like it has been blocked by the deployment firewall. Let me figure out where. And I can come in here and see, okay, there's problems with the vulnerabilities assessment. So we've got a couple of highs and a critical here. I can then go ahead and take action to say, hey, I want to open a hero ticket, or I want to go ahead and provide an exception for this. And if I go ahead and do that, I can actually enter that exception, or I can ultimately get disposition on these alerts, and then ultimately come back to the deployment firewall and ultimately re-trigger that deployment. So if I'm from an RBAC permissions perspective, if I have those permissions within the tool, I can come back and ultimately re-trigger the deployment after I've mitigated. Or I may have to wait because I entered a hero ticket, and I'll wait for that to resolve and ultimately be able to re-trigger this deployment. So again, I think it's really handy to be able to sort of ultimately see what's holding something up, and then ultimately, if you want to see what the exceptions are within this, you can certainly go ahead and do that and see what exceptions were documented and manage those that way. You can also see what are the rules specific to this application stack. So again, we've got the ability to set rules at both a global level and at an application level. And again, all these things would be evaluated by that firewall. And again, giving you the ability to go ahead and actually manage all those things, whether those things be, again, security related or validation that the test had passed in the systems that from, or again, you can overlay all of your compliance rules and regulations here to make sure that those are all being complied with as we go through. So again, I think it's very, very straightforward, very, very simple to sort of get up and running. And I think that was one of the things we wanted to make sure of here, is that we didn't put up large impediments to being able to not get started with us, or we didn't want you to have to come back and say, geez, I got to now change the things that I'm doing to ultimately, or change the way I'm doing things to ultimately get the benefit of something like this. We want to actually work within the tooling that you're currently using today. And again, I think it's fairly straightforward to be able to look at these things. And if we look at where we are at the application level and that application status, we can also drill into as the next layer down in the hierarchy, any of the services that are deployed as part of that application. So again, we're looking at a multi-layered scenario here where we've got an application layer status and a status that rolls up to that application as a member of that application at the service level. And so again, we're capturing all of this information, and again, as it flows through the deployment firewall, and looking and evaluating that against the rules that we've put in place. And again, firing off alerts in the event that, there was an alert here, there was a problem, and giving you the ability to take action. And I think that's something, guys, that's really important, is that ability to say, hey, I don't want just to have something tell me something's bad. I want you to be able to tell me how to do something about it. Like, what do I need to do? And I think that's another piece of this, is we sort of look to tap into the various tools that are in your ecosystem, or take advantage of public domain information like the NVD database to ultimately be able to surface suggestions as well in terms of how to get around something, or how to mitigate or provide remediation to some of these things, and ultimately make sure you're deploying safe and orderly software. The last part here that I want to go through is a couple of the other ancillary pieces here. As we look through this, and we look at things like audit, we're going to be able to provide, as part of that sort of overall experience, and sort of the deployment firewall is sort of the implement to enforcement in the way we outline rules. But obviously, the other thing that's important here is the ability to say, hey, I want to know when something was deployed. I want to know where it was built. I want to know who approved it. I want to know what cluster it was deployed to. So all these things, again, because we are tapping into the data in your ecosystem, we're going to be able to go ahead and actually bring all that into one place. And, again, you can, work with an auditor and guarantee the efficacy of those things, because we're not just, you're not just collecting data and throwing it into a random data warehouse. This is an application stack that ultimately is responsible for tracking these things, providing this information, and ultimately, like I say, bringing you to a spot where you're ultimately going to deploy safe software, or stop you in the event that something has changed and there's unsafe software out there, or unsafe software that's being speed up for deployment. So with that said, guys, let me go back here. And that's really sort of what we had in terms of presentation. And hopefully that was useful from sort of, one, understanding sort of the why we came up with this concept, and two, giving you an overview of sort of how it works. But let me stop there and see if we've got any questions for either myself or Gopi from the audience. Mark, I don't know if there are any questions in the chat.
Yeah, please enter any questions that you have. And this is for both Bob and Gopi, and it's pretty interesting. The area around sort of software delivery and security, and how the fact that it's a very dynamic period. A lot of focus has gone sort of pre-build or up to the build with the SBOM. But why do you think there seems to be such a vulnerability or desire, need to drive post-build? There's a lot of, it seems like there's a lot of exposure that needs to be addressed. Maybe you could comment on that.
Yeah, so
Okay.
right, Mark, that's a very good question. So what we've seen is in the last 1 year, 1.5 years, the type of attacks on the supply chain has increased. So if you go back 3 years, most of the attacks would be in your production environment. So you have something deployed in production, someone trying to exploit the vulnerabilities in the production alone. But now what we started seeing is that there is an increased surface area in the delivery chain itself with the use of open source software, open source libraries, and the build systems themselves. So if the supply chain is compromised, the effect can be pretty dramatic, as we saw with the SolarWinds or even with the Circle CI exploits. So that's one of the reasons why there is an increased scrutiny in what we can do for supply chain. So most of the tools until now were point tools. They will go look for vulnerability analysis or SAST, software static analysis. But with the increased in area, it doesn't cover things like post-build, pushing the artifactory, or verifying that the artifacts that are created are the ones that should be deployed to production. We had a small incident in one of our customer environments that the artifact was tested, but a newer build was pushed into the repository. And then when they went to the production, instead of pushing the one that's tested, they pushed the one that went into the repository, which was not tested for the production. And they had it downtime for 2 hours. So these are all kind of things. Then this could be malicious intent too, if you look at from the security perspective. So we want to make sure that these kind of things can also be prevented from going into the production and causing security issues. So that's why the process and compliant requirements are very critical for the delivery process itself. So it's not just the source code and build time with open source libraries, but also the delivery process and continued security end to end.
Yeah, very good. Hey, Bob, when you think of the product itself, the idea is, you have risk management, right? And how do you automate risk? But also you have to sort of, and there you have to sort of prevent vulnerabilities and resolve issues. But how do you also do that and uphold compliance? So those are not different things in some ways. So maybe you can talk about how the product implements sort of this automation of risk and compliance. You talked a little bit about that. Maybe you could elaborate more on it.
Yeah, of course. And I think that's a great question, Mark. And I think at the end of the day, we're beholden to three, sort of the three-legged stool, right? One is we have to operate in a secure manner. We have to operate in a compliant manner. And by the way, the business is not going to give us a break here. We're expected to operate at scale and velocity, right? So if you think about those things, having automation and having a tool at your disposal like a deployment firewall that can automate the evaluation of those rules and ultimately make sure that anything that looks or even smells unsafe is stopped and evaluated, right? Versus, hey, let me stop and evaluate every single thing. I'm now narrowing the scope of what I have to look at based on the fact that I have a rock solid firewall in place that's going to block or at least pause or stop any of these deployments that look suspect. I think the other side of that, I think you mentioned around compliance is super important because listen, anyone that's been through an ISO 27001 audit or a FedRAMP audit knows these guys are all from the show me state, right? They want to see. They don't want to just look at your SDLC. Maybe the first time through, they'll look at that and say, this looks great. They're going to come back in a year and say, okay, now prove to me that you've maintained what you've written in this document that you gave me a year ago. And I can't tell you how many organizations that I've worked for that's sent them into a tailspin because now you've got to go looking for all this information. It's there. You just got to go looking for it all. It's not all in one place. It's not clean. You can't just simply say, okay, here's an attestation report or here's a file that proves that we did all these things. And oh, by the way, here's the system that we used to do it, and here's how it collected the information from the various elements of my CI/CD system. Again, that is going to be a time saver. It's going to allow you to operate at scale. And it's ultimately going to go ahead and make sure that the deployments that you're doing The ones that comply with all the rules continue to sort of zip through the system. The ones that don't are the ones that get stopped. And you really sort of, again, narrow your focus to just those problem deployments, and everything else can continue to operate at the scale and velocity that your business expects. So I think it's incredibly important to add automation to this process and not try and do the typical, sort of dance every time an auditor is going to come in, or worry about that compromise you might have to make around security and safety versus speed and velocity. All right. So I think that really sort of sums up, at least in my opinion, why something like this is so important.
Yeah, it's really about removing the constraints and going faster, right? It's not about
That's right.
stopping things. It's about making sure you can go faster. One final thing, because I know we're coming up on the quarter tell. What about the proliferation of open source? And as new vulnerabilities hit open source, a customer might have something deployed, across their environments. How do we manage, that kind of thing? Maybe Gopi, you could lead off on the issue of open source and security and how to monitor and manage and protect, environments.
Open source really helps innovation, right? So in what we've seen, this Gartner studies is that almost 80% of the software that shipped today uses some form of open source in it. Or software that shipped have 70% of the components in open source. So that's really important for us to understand how we can secure the open source. So there are various techniques that we are using. I think Bob went through some of it, right? How do we identify what the vulnerabilities exist? And there are software that have vulnerabilities, but you can take exceptions depending on how they're being used in your system. So those are some of the techniques that we use as part of the deployment firewall to reduce the false positives and help you manage these vulnerabilities that are there in the open source and be responsive to the business needs. Right? This not completely bogged down with the security issues and not be able to deliver at the speed of the business. So that's a fairly important point for us to solve, and deployment firewall goes a long way in addressing those issues.
Great. Okay, so we're coming up to the end. Bob, Gopi, any final comments before we wrap up?
Yeah, I think we're going to expand this. Sorry, go ahead, Bob.
No, I go, Gopi. Please go ahead.
Yeah, we're pretty excited about this deployment firewall and how this is shaping up. We would soon put out a release for the private beta to try these things out. And so watch out for the news from there. Go ahead, Bob.
No, you just read my mind. Great minds think alike, my friend. I was gonna put that commercial in myself. So thank you for doing that. That's awesome. Perfect.
Okay, great. Well,
Mark,
look,
I think that's those were our thoughts.
Okay, great. Thank you, everybody. Really appreciate everyone's time. So look, if you have any other questions, please reach out to us. More than happy to sit down and talk to you about this, analyze your environment. I know Gopi and Bob are both available to have discussions. We'd love to understand what you guys are trying to solve today and how are you securing your software delivery today? So with that, everybody have a really good day, and thank you so much for taking the time to join us. We'll see ya. Bye-bye.